Hello and welcome back to my channel. Today we're going to be talking about L'Hopital's rule. Uh, if you are in BC Calculus, you will know what I mean by revisiting an old friend. If you are in AB, then you are in for a treat. So we have limits that we are kind of working with, but a lot of the times when we get limits, especially like the one above, if we try to plug in 4, we are going to get indeterminate form, that 0 over 0. Normally what that means is we would have to try something else. We would need to do something else. In this case, we would have to do factoring the top and bottom and finding something that they have in common. Doing that, we would get something that looks like this. We can do reducing and all of these different things. That is something we can absolutely do. Unfortunately, when we get things like this, the limit as x approaches 0 of e to the 2x plus x minus 1 divided by x squared plus 4x, if we use direct substitution, we still get that form, 0 over 0. We can't actually do anything with the methods we know, so we have to try something else. This brings us to L'Hopital's rule. L'Hopital's says that we can look at our limits almost individually. So looking at the limit as x approaches whatever our value is of the top, if that equals 0, and the limit as we approach the same value of the bottom goes to 0, then we can look at the limit of the derivative of the top and the derivative of the bottom. So this is different than quotient rule. We're going to be looking at the derivative of the top by itself and the derivative of the bottom by itself, and then kind of bringing it back together for our limit. So, things that we need to know. This is a theorem, so it requires us to check conditions before it is applied. Those conditions being that we approach 0 on the top and the bottom. We have to be careful about notation, so we kind of need to write things in specific ways, and then we need to kind of look at how to apply the theorem in our problem. So we're going to look at this problem first. The limit as x approaches 4 of x squared plus 2x minus 24 divided by x squared minus 16. Just like anything else, we're going to go ahead and plug in 4 mentally first. 4 squared is 16 plus 2 times 4, which is 8. That gives me 24. When I add them together, minus 24 is 0. And then 4 squared is 16. 16 minus 16 is 0. So I know I'm going to get 0 over 0. Now I just need to show it. So I have the limit as x approaches 4 of x squared plus 2x minus 24. That is 4 squared plus 2 times 4 minus 24. And we have the bottom. The limit as x approaches 4 of x squared minus 16. Okay, I have now shown the limit of the top and the limit of the bottom both go to 0, so I can apply L'Hopital's rule. So we are going to look at the limit as x approaches 4 of. So now we're going to be looking at the derivative of the top and the derivative of the bottom. So if I look at the top's function is 2x plus 2, and the 24 goes away. The denominator goes to 2x, and then we're going to go from there. One of the things that sometimes is needed is sometimes we need to write out the fact that we're using L'Hopital's rule. So by LH or by L'Hopital's rule, we can say this limit of our original problem is equal to the limit of our derivative of top and bottom. So we took the derivative of the top and decided it was 2x. The derivative of 2x is 2. Derivative of 24 is 0. Derivative of x squared is 2x again. Minus 16 is 0. And then we're going to go ahead and plug it in. So I have 2 times 4 plus 2 divided by 2 times 4. If we're worried about it getting 0 over 0 again, we're going to want to go ahead and do that mental check first, and then we could potentially do this process again. But we don't need to in this case. So 2 times 4 is 8. So we get 10 over 8, or 5 over 4. Okay, we're going to do the same thing, but with this other function. So the limit as x approaches 0. E to the 0 power is 1, so I know e to the 2 times 0 is going to be 1. So we'd have 1 plus 0 minus 1, all goes to 0. And then there's x's in the denominator, so I know they're both going to go to 0. So we have the limit as x approaches 0 of e to the 2 times x plus x minus 1, e to the 2 times 0 plus 0 minus 1. And we look at the bottom. Okay, so we get 0 on the top and 0 on the bottom. So by L'Hopital's rule, the limit as x approaches 0 of our original problem, e to the 2x plus x minus 1, 2x plus 4, equals our limit of the derivative of the top and the derivative of the bottom. Okay. Oh, I combined these. This is our original x squared plus 4x. I wrote out the derivative, which would be 2x plus 4. The derivative of the top, the 1 goes away. We're going to get a plus 1 at the end. And e to the 2x is e to the 2x times the derivative of 2x, so 2e to the 2x. If we go ahead and plug in 0, 2e to the 2 times 0, plus 1, 2 times 0, plus 4. So 2 times e to the 0 is 2, because it's 2 times 1. 0 plus 4. So we get 3/4. L'Hopital's rule is one of these really nice ones where like everything is just made easier with it. The biggest problem with L'Hopital's rule is the notation that sometimes they are willing to accept and sometimes willing not to accept. Okay. The graph of f of x is shown and consists of 3 line segments. The function g is twice differentiable with the selected values given in the table. Use the information from the graph and table to answer the following. So the first one we have here is the limit as x approaches negative 2 of f of x minus 1 divided by 2x plus 4. Well, if I plug in negative 2 to the bottom, 2x plus 4 would go to 0. X being negative 2, if I look at my graph, negative 2 is right here, which is 1. So just looking at this, I know the top and bottom are going to go to 0, but we need to write it anyways. So I know this is 1 minus 1. X plus 4. 2 times negative 2 is negative 4 plus 4 is 0. So what this tells us is the limit as x approaches negative 2 of f of x minus 1 divided by 2x plus 4 is equal to the limit as x approaches negative 2 of 2x's derivative is 2, plus 4 goes away, the minus 1 goes away, and the derivative of f of x is known as f prime of x. So I'm looking at f prime of negative 2 divided by 2 F prime is our derivative, so if I look at the slope at -2, every time I go over 2, I go down 1. So -1/2. And we are going to divide that in half. So -1/2.